So last week we practiced identifying subshell counts as well as valence electrons in elements. So now we're going to put them all together and map out electrons on each subshell level of elements. And these are called Bohr models. So remember that elements in the periodic table are put into groups based on how many valence electrons they have. So if an element is placed into the seventh group of the representative elements, it will have 7 valence electrons. But for periods, if elements are put into the same period, they have the same number of electron subshells. So remember, there are no more than 7 periods. And if we pick the element calcium, calcium is in the 4th period, so it will have 4 subshells. Subshells can also be called orbitals. So if you hear me say orbital or subshell, they are interchangeable words. And the other rule is that stable elements have to have enough positives to outweigh the negatives. So protons have to equal electrons. The first step in making a Bohr model is that we have the nucleus, and in the nucleus we have to map out the number of protons and neutrons. So if we took beryllium, for example, beryllium would have 4 protons, and then its average mass would be approximately 9, so then we would have 5 neutrons. So no matter what, you always have to start with the nucleus of the atom that you are making the Bohr model for, and you have to identify the number of protons and the number of neutrons for that isotope. And then if beryllium is in the second subshell, second period, it will have 2 subshells surrounding it. Oh, that was poorly drawn. And the thing about this Bohr model is that it's going to show all the electrons in an atom. And so it's not just going to be the valence electrons, it's going to be all of them. And it has to equal the number of protons. So if we're dealing with 4 protons, then we must have how many electrons? Well, 4. So how these are mapped out is that the first subshell, no matter what, can only hold a maximum of 2. You cannot have more than 2 electrons in the first subshell of an atom. 2 and 3, you can have a maximum of 8, and then 4 is debatable. But the thing is that when we get to subshells, we are only going to practice up to calcium. So calcium is going to contain, by that point, 2 valence electrons. And actually, we have an example of it right here. So remember that we can only have 2 in the first subshell. So here they are, 1, 2. We would also identify our number of protons and neutrons. Calcium has a mass of 40, so we'd have 20 neutrons. Atomic number is 20 protons. And then we need to continue counting our electrons. So we should have 20 total electrons. Well, you can have at most 8 in the next one. So if we have 20, 2 plus 8 is going to equal 10, so we have plenty of room. So 1, 2, 3, 4, 5, 6, 7, 8. So that's a total of 10. So we have room for 10 more. Well, the next subshell, again, we can put up to 8. And then finally, we can count how many that we have. We have a total of 18 now, which means we have 2 left over until we get to 20. Calcium, being in the second group of the representative elements, means it ought to have 2 valence electrons. And when we distribute the electrons among the Bohr subshells, we find that it does have 2 valence electrons. 1, 2. So this is why calcium being in the periodic table is where it is. It's in the second group because it has 2 valence electrons. It's in the 4th period because it has 4 subshells to distribute all of those electrons. So if we go back up to our beryllium one that we drew up here, let's practice. Beryllium has 4 protons, so how many can we put on the first subshell? 1, 2. Well, We have 2 electrons out of 4 total, so how many can we have on our next subshell? Well, just 2 more. So 1, 2. And then let's check ourselves. So we find beryllium on the periodic table. It is in row or period 2 and group 2. So our Bohr model had 2 valence electrons, and it also had 2 subshells, so we did it right. Now, let's check this one. So we have a fluorine atom, and fluorine has 9 protons. Its atomic number is 9, so we have our 9 protons. It has an average mass of 19, so this isotope seems to have a mass of 19, so it would have 10 neutrons. Now, we should have no more than 2 electrons on our first subshell. And then we should have a total of 9 electrons. So 9 minus 2 is equal to 7. So it should have 7 on our outermost shell. So let's check it. We do have 7. Now, if we go to the periodic table, it should be in group 7, period 2 of the periodic table. So let's check. Period 2, group 7 of the representative elements, and there is fluorine right there. So that is correct. Let's do one more practice. Silicon. Let's do silicon. Silicon has 14 protons, and let's say our isotope will be fluorine 28. So let's find some space. So we draw our nucleus. Fluorine's, or not fluorine, silicon's atomic number was 14. Had a mass of 28. And then we draw our subshells. So it has 14 protons. We should have 2 in our first subshell. Okay, we've done 2 so far, so we need 12 more to get to 14. So let's do another subshell. We can have 8 in this one, so 1, 2, 3, 4, 5, 6, 7, and 8. So we have a total of 10, which means we ought to have 4 more. So if we draw a third subshell, we should have 4 valence electrons. So 1, 2, 3, 4. So by this Bohr model, we should be in period 3 for the 3 subshells. We should be in group 4 of the representative elements for our 4 valence electrons. So let's double check. Period 3, group 4. Period 3, group 4. And there it is. We did that right. So this is how you check your Bohr models. It should be in the proper group based on the number of valence electrons it has in the outermost shell. It should also have the appropriate number of subshells that correspond with the period that it's in. So this is how you check. Another thing about remembering how to do electron subshells, if we look at the periodic table, if we clean this up a little bit, what if it's hard to remember how many electrons go in each subshell? Well, there's a reason that it's shaped this way. If we look at our first period, how many elements do we see? 1, 2. If you think about the first subshell of an atom, how many electrons can you put? 2. If we look at how many elements are in our second period, we have 2, and then 3, 4, 5, 6, 7, 8. 8. Well, how many electrons can you put in your second subshell? 8. If we go all the way to argon, to 18, well, how many are in this period? 8 as well. So how many can we put in our third subshell? 8. The same number as our elements. So if you're ever wondering how to distribute your electrons, here's an easy way to do it. Let's say we're going to do phosphorus, okay? Well, Phosphorus is atomic number 15. It's right here. So let's think this through. Well, if we have our first subshell, we need to have obviously 3 because it's in the third period. Well, then let's do it. So 1 electron, 2 electrons. So we draw our first shell. 3, 4, 5, 6, 7, 8, 9, 10. So we need 8 more. And then we keep going until we get to phosphorus. 11, 12, 13, 14, 15. So I've done 5 elements in the third row, so I need 5 dots on my third subshell. So you can actually just count these out to see where you are. And remember, we're not going to go anywhere past 20, so the rest of this, don't worry about it. In terms of Bohr models, we're going to stop at calcium. That's really all there is to it. So go ahead and get started on your practice, and email me if you have any questions.